This is lesson 3.1 for pre-calculus, quadratic functions and models. We're going to be talking about two different forms of the quadratic formula, quadratic function, not the quadratic formula. That's something different. This is the quadratic function. And the general form is when we have it in the form of ax squared plus bx plus c, where a, b, and c are all real numbers and a does not equal 0. And that makes a lot of sense if you want to make sure you see this, that if a were 0, then we wouldn't have this x squared term, and you just have bx plus c, which is linear, not quadratic. So you absolutely have to have this term. This is pretty much the term that makes it a quadratic, the squaring function. And then these are just other things that are happening to the squaring function. Besides this general form, there is the standard form. Sometimes you've heard it called the vertex form, because in the standard form we have a times x minus h quantity squared plus k, where hk is the vertex. So sometimes it's referred to as the vertex form, but you'll see it in your book, and it is called the standard form of the quadratic function. Both the general form and the standard form have this same a. This is the leading coefficient for the leading term, the coefficient for the leading term, and this is the same leading coefficient. So they have the same a. That's important for later on. What we want to be able to do is to easily convert back and forth from general form to standard form and from standard form to general form. I'm going to show you the easier way to do the easier conversion, which is to go from standard to general. Because to go from standard to general just means to expand out. We've got this ax squared, and we're just going to expand that out. To expand that out is to multiply it, and we end up with a times the quantity x squared minus 2xh plus h squared. And then finally at the very end, we're going to add k after we do all that. So we're going to distribute the a. And at this point, you've got this first term that has the squaring, which tells me it's quadratic. We have this other term here that has an x in it. And then these two terms, they don't have any variables, and these all, the letters A, H, and K, they all represent numbers. So this is going to be one single number once I know what A and H and K are. They're not variables. So I'm going to rewrite it this way, where I've kind of grouped it, where I have this negative 2AH that is being multiplied by x, and I'm going to group these two things together because they're going to make a constant. And this is where we can see that just simply by expanding, we have taken this standard form and we've put it into general form. If you notice that we've got our a's right there, we've got our b's, and we have our c's. And so this tells me something else. Now that I know this is what's going to help me convert from general form back to standard form, so that if I had ax squared plus bx plus c, that I could easily write it in this format. And how I do that is I notice that the b is negative 2ah. That's what this is showing me. And if b equals negative 2ah, what I need for the standard form is h. So I'm going to solve this equation for h. And I know the h of the vertex is negative b over 2a. But how do I find my k? Well, we could memorize all of this, but this seems an awful lot. And here's an easier way. First, I remind you that to find the y, the output of any function, we simply input the x and evaluate. So if we know the h of the vertex, we plug it into the function for the x value and evaluate, and that will tell us our k. Meaning, we're trying to find hk. If we have our h, we plug it into the function to find the k. And we know our h if we have the general form, because h is negative b over 2a. We find out what this number is, plug it into the function, and then we will find our k. So let's see an example of this. Here is the general form of a quadratic equation. And we're going to write it in standard form, meaning the HK, the vertex form. We're going to graph it. Make sure when I say graph that you use graph paper. And when you graph it, you need to show in your graph, and then you also need to verbally state in written form the following pieces. The vertex, the line of symmetry, x-intercepts and y-intercepts, and if they have them. State if it has a maximum or minimum, which one it is, and then what is the value of that maximum or minimum. So here we go. Here's the equation. We recognize that our A, our B, and our C from the equation are -3, 12, and -13. We know that H equals -B over 2A, so we write that as -12 over 2 times -3, which reduces to 2, so we know that our H is 2. We're going to take that 2 and we're going to plug it into the function. So we're going to do f of 2, and when we do that we get that it equals -1. So we now know that our HK, our vertex, is 2, -1. So we have the A from the original general form. We have the H and K that we used by using the formula -B over 2A for H and then plugging that in to find our K, and then we can write it in standard form. There are other ways to go from general form to standard form. There's something called completing the square. There's also finding the two x-intercepts and averaging them to find your H. But sometimes parabolas don't have x-intercepts, so that method doesn't always work easily. But there are, and there's other methods as well. This is just a method that I'm showing you here that you now have another tool to use to find the standard form when given the general form. At this point, we're ready to graph, and you'll see even in this video, this is graph paper here, so you have it on graph paper. Whenever you graph, you need to write your axes. You need to label your axes. So my vertical axis is f of x. My horizontal axis is x. You need to put the scale on here, and so I counted out 10 squares and went to 10. I counted up to 5 squares and put a 5. So now you know that each one of the little squares on my graph paper are 1 unit by 1 unit. You have to have that. I will grade against you if you do not have your axes labeled and your scale labeled. We're now going to graph the point 2, -1, and that's going to be our vertex. The next thing I'm going to do right away is put in the line of symmetry, because the line of symmetry is always right through the vertex, and that is a vertical line, so it is x equals. So x equals 2 is the line of symmetry. And now we're going to figure out some points on the parabola. And there's a lot of ways you could just plug numbers in, but an easy way to think of it is from the vertex. This is I call it the Parabola Dance. And from the vertex, you step 1 over, and then you're going to move up or down 1 squared times your A. And remember, in our problem, A is -3. So I'm going to go over 1 and down 1 squared times -3. So down 3. And I put a dot right there. Now I'm going to do the next one. I go back to the vertex, always starting at the vertex, and we're going to go over 2, and then we're going to change vertically 2 squared times A. Well, 2 squared is 4. 4 times -3 is 12. So I'm going to go down 12 units. So I went down 12 units, and I put a dot. And now, once I have this, I've got 3 points here. I've got the vertex and 2 points on one side of the line of symmetry. I'm going to use symmetry. This point on the parabola is 1 unit to the right of the line of symmetry. So I'm going to put another point 1 unit to the left. And similarly, down here, this point is 2 units to the right of the line of symmetry. So 2 units to the left, I'm going to put another point. Then we're going to connect those carefully, as easily as you can. They don't have to look perfect like a graphing calculator or a computer, but parabolic shape. And from this I can see something, and that is that my y-intercept is right here. And what else do I know? I know that there's no x-intercepts. I'm looking at this graph. I see there's absolutely no place where it crosses the x-axis. And I can also see that this is a maximum. And the maximum value, and this is important, the value is how high is it. If it was a minimum, if I had a parabola going up, I would have a minimum, and the value is still what is the output, the y value of that maximum or minimum. So this one has a maximum, and it's a value of -1. Now, you don't write all these things in the picture. You draw the parabola, you have the points, and you show the line of symmetry. But you're supposed to state these things where there are going to be questions like, what is the vertex? And you will state it. And then what's the line of symmetry? And you state it. You state all this. In the end, your graph just looks like this. So you don't have all of the information written here other than the parabola. I've got my y-intercept here. If I had x-intercepts, I would have them marked carefully here. And you have your line of symmetry. And because you have scale and axes labeled, I can see in the picture all of the information, but you have to state it yourself so that I know that you know what those pieces are in this graph. So, you now have two problems to do, where you're going to do the exact same things, write in standard form. They're given in general form. Write them as each one of them in standard form, do the graph, and answer all the questions.